Welcome, everybody. My name is Kathy Zyme, and I really apologize for the technical difficulties. Thanks for your patience. All right, so this presentation is about remodels with Brian Cowan and Steve Hannan. We're going to start the presentation by acknowledging that we're on the traditional land of the first people of this region, and we want to honor with gratitude the land itself and thank the tribal people who've been faithful stewards of the land, water, and ancient history of life. Peace, dignity, and equality on a healthy planet. This is from the United Nations, and while it's simply stated, it deeply resonates with our committee as we think about you and the need in our communities at this moment. So we believe that you are a group of people who can set an example for how to support one another and move through this time together to arrive in a better place. These are our sponsors this year, and we really want to thank them. The sustaining sponsors are Dunn Lumber, King County Green Tools, and Farrow's Creative. Our supporting sponsors are too numerous to mention, but we really could not do this event without them. So please make sure to check out all of these great companies. And finally, please note our contributing sponsors. All of these companies and organizations are who have helped make this event possible, so please help us thank them all. Before we get started, we have a few housekeeping notes. When we finish our presentation, you'll see a floor like this picture. I think most of you are familiar with using Remo by now. If not, please ask someone at your table to help. If something really doesn't seem right, many problems are resolved by moving to another table or leaving the meeting and coming back in. If you have mic and camera issues, look to those 3 bars in the upper left with the purple circle around them. You can find information on how to troubleshoot that there. For help from one of your hosts, look for a yellow star like you see enlarged on the right. And now I'm excited to introduce our speakers. So just FYI, this is going to happen in 2 short sessions. First, Brian is going to speak, and then we will have Q&A for Brian. And then Stephen's going to speak, and we'll do Q&A for him. So when you have questions, please type them under the Q&A in the chat bar. And now I am going to turn it over to Brian.
Okay, can everyone hear me? Okay. Welcome. Hi, my name is Brian Cowan, and welcome to our talk on remodeling to reduce carbon. A little bit about me. I work as a building performance specialist and carpenter at Carlisle Classic Homes, and I hold certifications through the Passive House Institute US as a passive house builder and consultant. I'm a certified building analyst through the Building Performance Institute. I'm also very passionate about building with lower carbon and spending time outdoors. So we're going to talk mostly about a project that I did with my partner Michelle on our North Seattle house over the summer of 2019 to make it more comfortable and lower carbon. Okay, so who we are 2 passionate environmentalists excited to tackle big projects. Both of us grew up around construction, so taking on a remodel was something we were looking forward to. We had a 980 square foot Rambler with an uninsulated attic, siding that was long past its useful life, 11-inch overhangs from the hip and gable roof, and an uninsulated slab. So this was a pretty basic home with a lot of flexibility. And how we did it was slowly. We spent a very hectic 2019 summer, and some of the aspects of the project still linger today. It was primarily an exterior remodel, which allowed us to modify plumbing, electrical, window placement, earthquake retrofit, and improve drainage. So through my involvement with Passive House, I like to think of better buildings through the lens of passive house. And so these 5 principles are always kind of top of mind. Thermal insulation, passive house windows, adequate ventilation strategy, airtightness, and thermal bridge reduced design. So the wall was kind of primarily what we focused on. The scope of our remodel went from the slab all the way up to the top of the top plate. And we'll walk through this. So the aspects of quality insulation and airtight construction were very important here. We'll cover air sealing and insulation, carbon impact, building, and siding. So we have a continuous air barrier from the slab to the top plate. Above the top plate is what I'll talk about in a bit. So the connection uses Viscon, which is a liquid applied air barrier from 475. We used pretty much all of 475's suite of products here. And then that air barrier, that air barrier transitions from the existing slab up the shiplap to about the second course of shiplap here. And then our Mento 1000, which is out here, gets fastened directly back here. It's stapled kind of backwards and upside down and then taped over top. And then when we add the insulation, we can fold it all the way over that detail. So our air barrier transitions to the outside of the wall assembly. So the carbon impact, we used a lot of Gutex. So Gutex is a insulation made of wood fiber. So it's reused, or it's wood waste product pressed into a tongue and groove board. And the tongue and groove nature of it adds a lot of air tightness and makes the product really easy to work with. We also did a lot of wood reuse. So all the rain screen battens were kind of leftover material from some shipping containers that we get on a regular basis. So 80% of our rain screen was upcycled wood content. And then the details allowed us to reduce the use of EPS to below grade. So EPS was chosen because has a lower carbon impact as far as foam goes, but we still wanted to limit it. And then we went with a really simple design. Most of the house, we really liked the layout. So we minimized framing. In most cases, made windows smaller if we were reframing windows. So the building, again, we used the Gutex. We like that it has a great firmness, so it's not compressible, versus some like mineral wool is a little harder to work with and get everything to plane out. Gutex, you can press hard against it. We were able to install the Gutex with just like a single cabinet screw on each panel, and then the rain screen battens kind of tie it all together and hold it in place really well. So it's easy to cut and shape, versus the EPS, has a lot of static and creates a big white staticky mess. This just gets swept up and put into the compost. And it's really lightweight and manageable, the panel sizes. We used the whole suite of 475 products, the Mento, the Vanna tape, the Gutex, and the Viscon liquid applied air barrier. And then the rain screen and hardy siding to add resiliency. So the siding, we just did a lot of kind of really good flashing details. And then the 3/4 inch rain screen will add ventilation, so the wall can dry out because it has a very low heating load in the building. So we want to incentivize moisture to leave the building and be able to drain out and either rise up with the air current or fall down with gravity. And the Mento 1000 kind of works like a Gore-Tex jacket in that way. And then we have the 6-inch Hardy lap siding, which gives us a little more fire protection. It's also good for long term. It's the paint is going to hold on it really well with the rain screen behind it, so it's not going to get a lot of moisture trapped in there. And then we used cedar trim for all the corners and window trim because it's a local product that has a long history of working really well in our area. So the foundation, so again, these passive house design principles of no thermal bridging and airtight construction. So we did a lot of air sealing around the parts of the slab we could access, and then below grade insulation. So here's what the detail looks like from the start. So we brought the EPS a couple inches above the foam, allowed us to fasten into wood versus the old concrete. In some spots we had a footing, so we had a lot of area to fasten the foam to. Where we just had the slab that didn't have a footing, we found that concrete to be really brittle. So holding the EPS up a little higher gave us a good way to kind of securely fasten it. And then below that, we applied some glue. And then our drainage plane here, so this is a piece of Viscon or of Vanna tape. So we had the custom flashing vent that transitions from the outside of the second layer of the EPS foam to the outside of the first layer of EPS foam. And then on top of that, we put the Viscon tape so that any water coming down will find its way to the outside of that flashing. And then our air seal will go from kind of midpoint on the slab all the way up so that we can tie in up here where the pointer is. We'll tie in our Mento 1000 air barrier, and then that will wrap under the Gutex and then be pulled tight. So I think this is a detail that's kind of we invented, or I came up with on this project. Lucas said he hadn't seen it this way, but we've done it on a couple other projects since, and it works really great. So yeah, foundation. So below grade insulation. We have a front porch and a back porch. So we wanted to have, no thermal bridging from either of those. So it involved doing a saw cut a couple inches back and then jackhammering all the concrete out, adding the foam in, and then bringing our concrete right up to that level, as well as putting in some drainage below near the footings. We also found that our house was partially built on a septic tank, which seemed like it had never been used. But as we were kind of doing some details in the back of the house, we found this layer of concrete that just seemed to go and go and go. And it was about a 8-foot by 5-foot tank. So we were able to kind of cut that all up and reduce that thermal bridge with more foam. So the windows and doors, superior windows is the design principle here. We'll talk about Indo windows and installation, triple pane tilt turn windows, and the kitchen door. So I'm the local dealer in Seattle for Indo windows. It's a window insert that kind of presses right into place like Tupperware. We like the placement and size of most of the windows in the house. Large south-facing windows bring in a lot of light into our living room, dining room, and kitchen. The north side of our house has bedrooms with northern-facing windows that were downsized and moved upwards in some cases to give us views of the trees in our area rather than the neighbor's fence right across the right outside the window. So yeah, these Indo products are made locally in Oregon, custom built to fit the dimensions, even the really big windows. As you can see here in our photo, we have some bigger picture windows, and they reduce drafts. In this case, we went with some that have a UV protectant on them, so they'll reduce UV light penetrating into the house that would fade any furniture or flooring. And they also stop drafts. So what we had here in these openings were double pane IGUs. So we were able to take those out, kind of reframe the opening, redetail it, and put them back in, and then add the Indo window over top. So it essentially gets us close to what a triple pane window would be. And they're also customizable. So we had this octagon shaped window that our neighbors kind of recognized. You know, if we meet someone on the street in our neighborhood, we just say we're the house with the octagon window. So we didn't want to get rid of that. We wanted to preserve it. So we were able to redetail the opening, put the double pane octagon window back in, and then have a custom template done for the Indo window so it could go on top of it. This also allowed us to shift the plane of the window panes out further, so it gave us more room for a window sill, and then also to accommodate the Indo windows and blinds. For the operable windows, there were only 5 operable windows in the house, so we went with European tilt-turn windows. Other than a long lead time, we were pretty impressed with the product. So we can tilt them open to have some ventilation, which will be kind of safely kind of locked open. You can't open it any further than it is kind of in this orientation, or you can turn it open like a door for egress. And they have a multi-point latch system, so it gives them a superior seal. And then for the kitchen door, we had a half-light window door that was single pane. The kitchen was always kind of one of the colder parts of our house around that door, and we were able to upgrade it to a half-light door that has a triple pane window from a company called Provia that works with Alpen windows. So that half-light door is an R5. It's not a multi-point latching system, so it probably leaks a little more than we would like, but it does really good for a door with a window in it. So the next thing, the other component we upgraded was the mechanical system. So our design principle here is ventilation with heat recovery. So we'll talk about cutting the gas line, ventilation, HVAC, and hot water tank. So yeah, one of our main goals to reduce carbon was to get off of fossil fuels and get closer to being able to be on solar power at some point. So PSE was able to remove the gas line and at no charge. There was a couple week lead time, but they did a good job of working around our schedule. They weren't able to remove the meter and cut the gas line as quickly as we wanted to, but they accommodated us by removing the meter and just leaving the stub out here, which allowed us to kind of continue our building details around and keep the project moving forward. So this should account for some annual utility savings just in service charges and, having 2 different bills and streamline our monthly bill management. So for ventilation, we went with the Lunos fans, also from 475. This is a great strategy for remodels. And so one fan, these pair of fans work in concert. One will run one will intake for 70 seconds while the other exhausts for 70 seconds. And the one that's exhausting is charging up this ceramic core. And then when they switch directions, it's bringing in air through that kind of pre-tempered core. They've been great. Our house is only 980 square feet, so we probably could use 2 of these. But what we're thinking is in the future, maybe putting a second story on the house. And if we do that, we want to have a ventilation strategy that kind of ties both floors together. So for now, this ventilation strategy works really great for just 2 of us living in the house, me and my partner, Michelle. But in the future, we might want more ventilation if we have more square footage and potentially more people living here. They also filter out the air, so they have a MERV 5 filter, but it sounds like Lunos just is now giving an option for a MERV 16 filter. So that should be an asset for more smoky summers if we have to deal with more forest fire smoke. So the mechanical system, we had a 95% gas furnace that was ducted to all the rooms in the house. And because we put on 3 inches of exterior insulation, the house is really well heated with just one single head from a heat pump. This unit serves kind of our living room, kitchen, and then can shoot some warm air into our bedroom. So it really meets our needs very well. And it's also, if we do the second story addition, we can tie into the exterior unit and just add more heat pumps. And we kind of tried this out, knowing that we could also tie in another unit if we needed to, like a ducted unit to some of the other bedrooms if they weren't warm enough. But kind of our experimental stage right now seems to be working really good. It's really warm in the house, and it also provides cooling. Cooling, you'll see later, is not an issue. We have the rest of our slab is uninsulated, so we have no problem with cooling in the summertime. In fact, one day it was 93 degrees out and it was only 77 degrees in our house without the AC on. So the hot water tank, I worked for a couple of years doing energy audits for the Community Power Works program and saw all kinds of water heaters, but I went home every day to my water heater, which lived in what we called the shed of shame. So our water heater was literally built into a shed outside, and to make matters worse, they ducted the dryer into that combustion room where the gas water heater was. So we were thrilled to get rid of that, and we decided to just go with the standard electric tank. There's some great deals out there for just a stainless steel tank, and we didn't really want to overthink it too much, and wanted to just get something in there that would be easy to kind of do it ourselves. So we just kind of switched the plumbing around. It works great for the 2 of us, and we might upgrade at some point to a fancier hot water heater, but for now, this worked really good. So the carbon impact, we didn't do a full life cycle analysis, but there were certainly things that were, carbon was a big factor in a lot of our decision making. So obviously the shingles, the house was in really rough shape, needed to be resided. So those shingles, and this is just kind of accounting with the half of the weight being carbon. So that had an impact. We had to take a dump truck full of shingles to the landfill. But the Gutex insulation accounted for making up a lot of that carbon impact. So it was kind of also one of the reasons why we went with 2 layers, because we knew that we were going to have some deficiencies in the slab, and we wanted to kind of have as positive of a carbon impact as we could, and that balanced well with having a more efficient building. So we went with the 2 layers of the Gutex. And then repurposing the rain screen battens helped a lot. The EPS foam, impacted us a little bit, but we tried to use as little of that as we could. So then kind of looking back through the passive house lens, we wanted to see, we're kind of balancing between being kind of low carbon and having the best building. And so I did some WFI modeling, and here we can see kind of 2 scenarios, one where the house meets passive house standards and one where it doesn't. With the uninsulated slab, our heating demand up here at the top is pretty high. If we put R25 over the slab, it brings us down into a reasonable range. But right now, we would have had to raise the heights of all of our doors. R25 insulation is going to be pretty thick, so we would have had to have probably tackled that all at once, which would have made the project a bigger undertaking. So for now, we're kind of pretty content with focusing more on a lower carbon building rather than a building that meets passive house standards. We do have a floating floor here, so we might be able to add 1/2 inch or 3/4 of an inch of a material in the future under the floating floor. But for now, we're focused on, just finishing up what we've already done and thinking into the future. So into the future, we're thinking about, potentially a 2nd story. But again, there's only 2 of us, so we're not sure that we need the space. But at some point, we want to bring the attic into conditioned space, whether it has living space above it or not, and then adding a PV array and then a ventilation system that would tie into the whole building, both floors. So in summary, when considering carbon impact, it is important to use low carbon and carbon storing materials to balance out the impact that building has on our environment. We could not have done this without all the collaboration from people in the Guild. This group exemplifies community and pushes the envelope. We learned a lot from this project. We are available to help you on projects where comfort, cost, and carbon are a big deal. You can visit our website at cchbuilds.com. Thank you, and I will now take questions.
All right, we have 3 questions so far. The first is from Green Home Solutions. Does anyone know what the carbon footprint of Hardy Plank is? Seeing as it's cement and chemicals, I've always been curious of its carbon swamp.
Yeah, I haven't looked into that. I know it's higher, but it's also has a lot of longevity, more than other kind of siding projects. So that was kind of a trade-off that we made there.
So maybe after the presentations, when we're talking at the tables, if somebody else has more information, they could share that then. A next question, Tom Balderston wants to know, what is your bug barrier between the EPS and the wood on your rain screen? Or yeah. Yeah, so we did do a core event on the top and bottom of the rain screen. But there is some Mento 1000 that is exposed, but I don't think that bugs are going to find that too tasty. So, but the Gutex is entirely covered. Like, there's no way for the bugs to get up inside there. He actually said between the EPS and the wood, and then I inserted the rain screen. So I'm not sure what he means, like if that's something different. Oh, well, so between the EPS and the wood, there's the Viscon liquid applied, air and water barrier. And then above that, there's layers of flashing and tape before we get to the
insulation detail where there's Mento 1000 that would kind of encapsulate the wood fiber Gutex insulation. So there's no direct path to get to the wood.
Okay, Tom is clarifying that his thought was that the bugs could crawl through the foam to the wood structure.
No.
Okay. All right, so another question from Michael Laurie. Do you have any documentation for the low carbon impacts of all the equipment choices? It sounds like you said you didn't analyze.
I haven't looked that far into it. I should, but yeah, not yet.
Okay. All right. One more question from Rob Valente. Love the assemblies. Was there added exterior insulation above the foundation band?
So the foundation, the EPS foundation just transitions to the Gutex insulation above. And then, so one thing we did at the top, because we have one thing that's super nice about having a house with overhangs is we were able to just kind of end the insulation near the top and fold over some Mento and kind of encapsulate it there. And then in the future, if we want to go up, we can just cut that back and continue straight up. Or if we want to build a soffit, we just build a soffit up against that.
All right, thank you so much, Brian. And now I think we are ready to shift over to Stephen Hannan. So Stephen, I'll invite you to turn on your camera and mic. And
hello, can everybody hear me?
yeah, we can.
All right, sharing my screen. So first I'll go through my presentation. My focus here is kind of balancing your energy use, how much energy you use and how much you can offset with solar energy. TJ Merrill did a presentation last week about solar and battery backup. That was kind of the focus of his. Mine is more on just the energy side and how much energy you use versus how much you can produce with solar. Whether it's 100% of your energy, 150% because you might be adding an electric car, or maybe you can only get 20%, but that's better than nothing. And I'm trying to explain how to balance those things. So at A&R Solar, if you guys don't know about us, our goal is high quality craftsmanship. We like to think of ourselves as a family-run business. We really work well together. We're a B corporation, so we like to practice what we preach and offset our carbon every year, but also do some social justice initiatives. And we're 100% employee owned, which I think is very important in this industry. So I'm a civil and environmental engineer. I went to the University of Delaware. Been a professional engineer since 2006. Here's a photo of my wife and I doing Mount Baker last April. That was a big climb for us, and we've been wanting to do it. And we skied down on the way out, so it was pretty fun. A little background about myself. My whole career has been really sustainability. Whether it's solar energy design, renewable energy assessments to look at wind, solar, or tidal. I've also done a fair share of environmental cleanups, fish habitat design and restoration, and energy efficiency audits. I've worked on the seawall project downtown. That was kind of a habitat and civil project that was pretty interesting. And here at A&R Solar, we've been doing residential solar has been my focus, although I've done marketing to help expand our commercial. So we do both residential, commercial, etc. In my undergrad career, I did research on solar energy and hydrogen fuel cells. And third on the list, what we'll hear more about today is our zero energy home. Zero energy because it's 100% solar electric. So everything in the home is run off solar. And then we also have a rain barrel to water our plants all summer. We use some of the water for rinsing our dishes. We'll actually fill up bottles and use that in the house and water our plants. So we offset our potable water. And then some of my hobbies are similar to Brian's, both like outdoors, skiing, hiking, swimming, and I also play drums. To show you some of the energy efficiency work I did in Alaska, I appreciate you guys talking about the Native American lands that we were on. This is two of the energy efficiency audits I did were in the native village of St. Michael's in the lower right, and the upper left was the Yakutat Tlingit tribe. That's their high school. So what brought us there was, they had very high energy bills, a lot of condensation, which resulted in mold in some houses. In St. Michael, they prefabbed homes in Washington and shipped them to Alaska. So they were just didn't have the correct R values. And the heating systems weren't built that way. So we really worked on prioritizing what made the most sense for energy efficiency. And then we also did renewable energy assessments to determine what worked up there. And it turns out solar does work really well up there because they have such long days in the summer. The other thing that is a big key in this is their energy is 50 cents a kilowatt hour. For those of you who may or may not know, in Washington, we're anywhere between 7 and about 15 cents a kilowatt hour. So things pay off a lot faster when they're 5 times more expensive than they are here. How do we analyze your energy use? Well, for your home, for your existing home, we look at your energy bill, whether it's Puget Sound Energy, Seattle City Light. Puget Sound Energy's energy portfolio is about 30% gas, 30% hydro, and 30% coal. Seattle City Light is mostly hydro, but as you know, we're in Washington, we're trying to remove dams like we did at the Elwha to reduce that. And the way we have to do that is the renewable energies, so we can remove those. So how do you model an existing home? If you don't live there, we actually can do energy modeling based on when your home was built and what energy systems you use. I'll go over to the modeling after this to show you what it looks like. If you're doing a remodel like Brian did or a new home, we also model that just to get us a baseline of how much energy you use. So the energy modeling, what do we input? We put the square feet of conditioned space, what type of HVAC you're using, how many occupants, etc. And then if you're using 10,000 kilowatt hours of energy, our goal is to offset anywhere between 10 and 100% of that, whatever makes sense. And if you're going to be switching something from gas to electric and therefore adding an electric load, we can factor that in. Or if you're going to add an electric vehicle. Brian talked more about the high level impacts of energy efficiency to how to really seal up the home. I want to talk about the low hanging fruit, the things that are easy to do. Some of them are free, just changing your habits, like setting your thermostat correctly, lowering your temperature a few degrees in the winter and raising the temperature in the summer. So that can really, and then only heat the rooms that you're in. You don't need to have rooms that you're not going to be in to be heated and cooled all day and all winter. Then it's eliminating ghost loads. If you've heard about the kilowatt meter, you stick it in the wall and plug things in. And I've done this with my laptop. If you plug it in and there's no laptop plugged into it, it still draws 30 to 60 watts of energy continuously. Well, if you have your laptop plugged in, when you're not using it year round, that adds up. And then also your cell phone, if you don't even have your cell phone plugged in, there's the little pack on there that still draws energy. Your TV has a light. So those are all ghost loads that, 1 to 5 watts times 24 hours a day times 365 days a year really add up. So that's how you eliminate ghost loads, is using a surge protector. You guys all know about insulating. That's an easy way to reduce what your HVAC load is. And a really cheap one is these socket sealers here. They're about $2 for a 20 pack, and you can do this for your home. It's a great COVID activity with the kids. All you need is a screwdriver, and it really helps seal your home. And it's quick, cheap, and easy. Caulking is also easy. A few tubes of caulk can really seal your home. And I'll explain what I did for my home to achieve that 100% offset. So solar energy, your use versus your solar energy balance. So let's take a home with 20,000 kilowatt hours. That's a high energy use. 10,000 kilowatt hours is about the average in Seattle. But say you can only get 50% of that with solar. That's great. 50% is a really good amount of solar energy offset. But if you just reduce your energy by 30% with some energy efficiency, maybe your heating, and reduce that to 14%, your solar can now offset 71% of your energy. So by doing energy efficiency, you can actually reduce how big your solar system is, and thereby reducing your cost of solar and bringing that down, and trying to meet in the middle. So it really pays to do both. It literally pays to go solar because of the federal tax credit of 26% this year, 22% next year, and then the energy you save over time. We deal with a lot of different style homes. I look at hundreds a year, whether it's all electrics, some gas, new, existing, etc. A lot of the new modern homes are going 100% electric, but their kilowatt hours could be really high if they have a heat pump water heater. An electric vehicle can add 3,000 to 7,000 kilowatt hours a year, which is pretty significant. When we said 10,000 was the average Seattle home, that could add 30% to an average home. With a 3,000, that's for 10,000 miles a year of driving equals 3,000 kilowatt hours. And some of these larger homes have, the pools, the saunas, and entertainment rooms. So, I've seen anywhere from 5,000 kilowatt hour use homes that are really low use. They do have some gas appliances, but I've seen, average between 10 to 20,000, but I've seen 30 to 50,000 kilowatt hours a year. And usually it either takes a very large solar system to offset that, or talking about energy efficiency. So my house project, I'm on the corner lot. I maximize the solar energy there on the roof to match an inverter size. If I added that one little corner spot, I would have had to go to a larger inverter, which would have been a few $1,000s more just to add one solar panel. So it didn't make sense to add one more. My system is a 5.4 kW or kilowatt system. It's about 5,000 kilowatt hours of energy. My tax credit for this system was about $8,000. So then I used that money to fund my HVAC system behind me. I got a heat pump, and that really helped bring down my cost dramatically. So with maximizing my existing home, I was only able to offset 60% of my energy, which was great. My energy bills for about half the year were zero, and then they were reduced in the winter. Now I just have the $5 base load all year, the base bill, but I have no energy use. And what I did is listed in the home efficiency section. I did the heat pump. I insulated the attic and my water pipes. I lowered my hot water temperature on my water heater. I caulked my interior and exterior, and then I also added a hardy plank exterior envelope like Brian did. I built it right on the existing T111, so there's a little air gap there, which actually helped seal and insulate the house. It is very comfortable now. So now I have 100% energy offset. So first I want to switch over to some of the modeling. So I have that pulled up on my screen here. So we use this home energy saver from the Department of Energy. You put in things like how many stories, how much your conditioned space is, your R values, your roof insulation R values, if you're what type of attic you have, etc., your windows. We also put in what type of refrigerators, your water tank, your heating, cooling, etc. And this gives us an output to determine how much kilowatt hours you might have on a new home. So this is how we get a baseline, and it doesn't include plug loads like TVs, entertainment centers. So we have to add that in after. So that's one way that we model. This is my home here. You can see the hardy plank on the side here, and the solar array, and you can see the HVAC ductless heat pump heat exchange outside. So by doing solar and a heat pump, I found that was really efficient way to offset all of our energy use. So it worked out really well. Some other things I know that you are all interested in, you're wondering about, what we do for low income housing. So here's one of our low income housing projects that we put a nice size solar array on. This is, pretty good size one. In Bellingham, we did a large commercial array. And we've also done schools, which I really appreciate solarizing schools. It's a long-term investment for a school because this is one of their highest energy costs is heating and cooling and their energy costs. So if they can offset that with solar, it really pays to have a long-term 30-year investment. I'm a fan of having them in libraries or any public building that has, paying taxpayers money to fund it. And so here's another elementary school, nice array on the metal roof. We can clip right to the metal roof. So it's a really nice way to offset their maintenance costs and their energy efficiency, their energy costs. Then we've also done some community solar projects. All over the state. So this is where you can actually buy a portion of the community solar. Say your house is really shaded and you can't, put solar in your house. This doesn't make financial sense. Well, you can actually buy portions of these community solar projects to do your part, to have some offset energy. These types of projects sell out your credits. If you could buy a solar panel, they sell those out very quickly. It was amazing. The one in Snohomish County we just did for the Snohomish PUD, it sold out in a few days. And then I just want to show you some of our other projects. We do anything from a small size home, people's garages, garage and home. We do ground mounts. These are photos of a lot of our all black. This is really nice for HOAs. A lot of architects like the all black modules versus the tuxedo. For instance, this is the tuxedo 370 watt output. This is on a membrane roof, so we tilt the rows since it was a flat rooftop, more of a modern home here. That's one that I designed. So I'll come back to the PowerPoint here, finish that off, but I just thought you'd want to see some projects. It's a good way to kind of visualize things. As I said, we do also power walls. So TJ went into detail about this, but this is just showing a triple power wall mounted on the garage wall. Some new construction here, flush mounted, looks really clean. On this roof, you can barely even see the solar. It is right there, really a clean look. It floats 6 inches over top of the roof. So you actually get some benefit of not taking on that heat gain since there's an air gap between the solar and the roof. So it's not quite as hot in the summer, which is a nice added benefit. We don't really calculate the energy saved there, but it is noticeable in the summer. We also did Washington's first car dealership, the Audi in UW, has some SunPower solar modules on there. We did the largest roof array on IKEA. And then we also do some, ground mounts and things like that. So, at A&R, we're happy to do assessments for your home or for your projects. Feel free to go to our webpage and talk to our welcome team. They're happy to take your information and talk you through going solar. And any questions you have. And now I'll just open up to any questions you may have. So I'll go back to the main Remo screen and go from there. Thank you for your time and joining me today.
Thank you, Stephen. So far, one question from George LaFonte. Have you looked at any projects with rooftop solar on a retail center flat roofs to power the homes around them? I looked into this for a center owner in Pennsylvania, but no one had answers at the time.
Typically, if you're doing a commercial building, you would run the commercial load on them at the building itself. It would get really tricky in the permitting to take that and then go to a residential grid, especially if all the homes have different energy uses. But I can see if we've done anything like that. But that's not something typical. Typically, the commercial and the residential are separate there.
Okay. Does anybody else have any other questions you want to add? Here we go. Rob Valenti, is there a marketplace for buying energy credits from solar farms?
Yeah, there is a marketplace for buying credits. That's what the community solar projects are, is where you can buy the actual credits for the parts of the solar array and the module. So we do have a few of those around. Our marketing team has been posting them recently. We have a few of them out there that have just come online. So I can look up that information for you.
Great. Any other questions, you guys? I'll just add that Lucas Johnson added a bunch of links in the Q&A for the carbon footprint of different products, if you want to check that out.
Oh, nice.
From the last presentation. So if we don't have any more questions, what I'm going to do is end the presentation. We'll all end up back with those tables, and you can look for the table for Stephen and Brian, and they'll be able to answer any more questions in person for, I think you guys are available for another half hour. So thank you guys so much for presenting and for sharing this information.
Yeah.
We appreciate it.
Thank you.
Okay.
Bye.